Hi, this is the final video where we're dealing with the 2017 higher tier paper, and it's paper 3 from Edexcel. And now in the previous videos we'd worked our way through to question number 15, so we're going to start with question 16. It is the final video in the playlist, so I would encourage you to follow the link below in the description, have a go at some of the questions and then compare your solutions. Okay, so question number 16 deals with iteration, which is becoming a bit more of a popular type question on GCSE, particularly with it being the new subject. Now there is a fixed way of doing this. It does look a little bit difficult when you first look at it, but really what we're saying is find the value of this formula using minus 2.5, and then when you've got that, plug that answer in to get the next values. Okay, so let's have a look at that in practically. We've got x to the 0 equals minus 2.5. okay, so that's the first value that we're given us, and we're being asked to work out the value of x1, x2 and x3. Okay, well x1 is going to be minus 2 minus 4 divided by, and I'm going to put it in brackets, squared. Okay, so all I'm doing is I'm taking this value and popping it into here, and then I'm going to be squaring it. Now it does take a little bit of time to kind of get used to these sorts of things, but if you work that through on your calculator, you will need a scientific calculator for it, and just be very careful about how you actually put the information into the calculator to make it work. I suggest you do use brackets when you're doing these sorts of things. So that's going to be minus 2.64. Okay, x2 then is taking this value of minus 2.64 and plugging it straight back into the formula. So rather than writing that, I'm going to put that in. But I just think for the sake of this, what we can do, if you're using a good quality calculator, you can write this as answer squared. Okay, and that again will work out for you, and you're going to get some very long number, 2.5739211028. Okay, well, providing you write that down and the examiner can see that, it's perfectly acceptable to write minus 2.57 actually on the answer point. Okay, then again we do exactly the same, so it is just a bit of a grind, this type of question, but there's no reason why you shouldn't be able to work it out, work it through and gain yourself a couple of marks on this particular question. And you're going to get on this one minus 603,767,255. okay, so that's going to give you a value of x to the 3 is going to be minus 2.60. Okay, and you can see that these values are approximate values of x in order for this equation to work. So explain the relationship between these values and this equation. Well, basically what we're saying is that this equation, x cubed plus 2x squared plus 4, it has been rearranged. So it has been rearranged to x equals minus 2 minus 4 over x squared. Okay, and therefore the values of x's are the approximate values. Okay, and that would be absolutely fine for that type of question. Okay, hope that's all right for you. Let's move on then to dealing with question number 17, which is a question that deals with bounds. Okay, bounds again becoming very popular, particularly in the higher end of the paper, so you do need to get to grips with working with bounds. The only difficulty with this one is it does say that the train travel along the track in 110 minutes correct to the nearest 5 minutes. Well, that's a new one on me. Okay, I've not seen that particular question before, but basically what we're saying is the time has a it's 110 and it's got a lower bound and an upper bound. Well, correct to the nearest 5 minutes means that the lower bound is 107.5, which then means the upper bound is 112.5. Okay, now that might be something fairly new to you, so please do have a look at that and make sure that you're okay with it. Okay, let's have a look then at the track. Okay, so the track is 270 kilometers long. So if we look at the track, we've got, this is 270, and that's correct to the nearest 10 kilometers. Okay, so that means then we've got an upper bound and a lower bound. Always work out the lower bound first. Okay, so we've got all of our information there. Okay, so what we're saying is, could the average speed of the train be greater than 160 kilometers per hour? Show how you got your answer. Okay, well, I think really, if we look at how this works for us, we've got the speed equals distance divided by time. Okay, so that's the formula we're going to be using. Okay, so the distance we're told is 270. Well, the upper bound of the distance, the maximum amount of the distance it can possibly be, is going to be 275. Okay, this time is something different because at the moment we've got this value as in minutes, so we've got to convert this because we're looking at kilometers per hour. So at the moment we've got a value of the lower bound of the time of 107.5. Well, that will be the lowest amount of time it takes. So it's the highest amount of distance and the lowest amount of time, but that is the lower bound in minutes, so we have to convert that into hours. So what we're actually going to do is we're going to say that that's 107.5 107.5 parts of 60 minutes. Okay, so that's going to give us an hourly value, which is going to be 1.7916 recurring. Okay, so you just have to be a little bit careful to make sure that you convert minutes into hours. And if you do that, then you'll be able to work out the speed of the train in the greatest amount of distance covered in the lowest amount of time means that that will be the fastest speed that the train can possibly do. It's the greatest distance in the quickest amount of time, the lowest amount of time and the greatest distance. Okay, so if we work that out in the calculator, you're going to get 153.488. Okay, so in this particular case, the speed would be kilometers per hour, and unfortunately the speed cannot be greater, not greater than 160 kilometers per hour. Okay, hopefully that's all right for you. Let's move on then to look at part B of this particular question. So part B of this particular question, it says Jack's assumption was wrong. The track was measured correct to the nearest 5 kilometers. Explain how this could affect your decision. Well, what it means then, if it's correct to the nearest 5 kilometers, it means there's less distance. Okay, if there's less distance, but it's also the same time, it actually means that the speed is reduced. Okay, so the effect it's going to have is make my speed reduce. So actually, no, still wouldn't achieve 160 kilometers per hour. Okay, let's move on then to question number 18. And question number 18 deals with working with circle and some tangents to the circle. So we need to figure out from this the length of the arc A, B, C. So it's all this area along here. Okay, so what we're going to do is we're going to figure out firstly what this internal angle is, because if we figure this out, we can figure out the length of this particular arc. We know the overall length, because then we can just use pi d for that. So let's just take a little bit of time to work this through. So what we're saying is that we've got this length along here, which we're told in the question is going to be 9 centimeters. Okay, so what we've actually got, where a tangent meets a radius, we've got 90 degrees. So we've got then a right angle triangle. So what we can say, if I just draw that right angle triangle, is we've got something like this. Okay, the right angle triangle, the hypotenuse of it is this length along here, which is 9. Okay, and then the adjacent of it is going to be 5, and in this particular case the opposite, which is AD along here, we don't know. Okay, but that's okay, because what I'm interested in is working out this value here, because if I work out this value here, that's actually this value in here, which means I'm a little step closer towards getting this overall angle. Okay, so if I can work out that, then I'm going to double it, because actually these are the same length, and if they are the same length, what it means is that I can work out this angle and use that to be able to work out my my arc. Okay, so I've got Sokotoa. And it has appeared once before in this particular exam. It does come up a fair bit. Now in this particular case, I've got my adjacent and I've got my hypotenuse, so I'm going to use the cosine rule. Okay, so I'm going to say that the cosine of, if you call it angle X if you like, is going to be equal to the adjacent, which is 5, divided by the hypotenuse, which is 9. Okay, well I'm not interested in the cosine. What I actually want is the value of the angle itself. So I'm going to use inverse trigonometry on my calculator, and I'm going to use cos to the -1. So if you press the shift key and then the cos key, that will give you cos to the power of -1, and that's going to be 5/9. If you pop that in your calculator, you're going to get this value then equal to 56.25 degrees. So what we're actually saying is this value is 56 degrees, which is this value here. So if both of those are 56.25 degrees, and they would be, because this is 9 and this is 5 and this is 5, so this is common to both of them. This is 90 degrees in both, because the tangent meets the radius at 90 degrees. So we can safely say that those are two congruent triangles. Okay, so what it allows us to do, if we want to work out the arc length ABC, what we're saying is that we've got a portion of that. What we've actually got is this angle of it. Okay, well this angle is made up of 360 degrees minus those two values added together, so minus 56.25 plus 56.25. Okay, so if I work that out, what it means then is that this particular angle along here is 247.49 and so on degrees. So that means that angle, if I call it A and then 0 C, is equal to 247.4979 degrees, and so it goes on. Okay, so we've got now the ability to work out the arc length, because we can use this fact by saying, well actually we're still going to use pi d to find the circumference, but we've only got a portion of it, so we can say the arc length ABC is going to be this angle, 247.4979, out of 360 degrees. So we've got that portion of it multiplied by just pi d, so it's going to be pi times 10. Okay, if you pop that in a calculator, you're going to get a value of 21.5982. So therefore, to correct to three significant figures, that's going to mean that the value of the arc length is going to be 21.6 centimetres in total. Okay, hope that's all right for you. A little bit tricky, does take a little bit of time to work through, but hopefully you'll be able to see that that will work for you. If you go to the website, you'll be able to download this particular image as a scanned image, a PDF file, and then you can compare your solution as well. Let's move on then to question number 19, which deals with inequalities. Inequalities, really all you can do is just treat this as just a normal everyday quadratic equation and solving a quadratic equation. So the way I would do this is I'd do 2 times minus 2 is going to be minus 4, and then what I want is two numbers that when I add them together, or rather two factors of minus 4, that when I add them together become plus 3. So in this particular case, I'm going to have minus 1 and plus 4, because when I add those two together, I'm going to get plus 3. Okay, so then I would write this out. This is very similar to the algebraic fraction that we dealt with a couple of questions ago. So when I write this out, I'm going to write this out as 2x squared minus 1, minus 1x plus 4x minus 2 is greater than 0. Okay, so I can now factorize these two, and in this particular case I'm going to factorize them for x, and I get 2x minus 1. And then factorize these two, and I'm going to factorize that for 2, and I get again 2x minus 1 is greater than 0. So I've now got the two factors of this as x plus 2 multiplied by 2x minus 1 is greater than 0. Okay, so what that means then, if you can imagine, this is the equation of a quadratic. So if I pop that onto just a graph here, what we've got is two values of x. We've got the value of x plus 2 is greater than 0. So x, it crosses the y-axis at minus 2. Okay, and then it also crosses the axis. If you work that through, you get 2x, if you like, equals 1. So therefore x equals a half. So it crosses at a half here. Okay, so the diagram actually looks like that. Okay, and what we're saying is that the value of this is greater than 0. Well, if it's greater than, I beg your pardon, greater than a half, it's going to be these values along here. Okay, similarly, the value of this is going to be greater than, less than minus 2. It's going to go in this direction, minus 2. So all these values are less than minus 2, and all these values are greater than a half. Okay, so we can write that down. We can say x is less than minus 2, and also x is greater than a half. And that's absolutely fine. You can leave it as that if you want, or if you wanted to, you could just bring that two together. So you've got minus 2 is greater than, or rather x is less than minus 2, and also greater than a half. Okay, hope that's all right for you. Let's move on to question number 20, which is the very last question in this particular paper. It's been a bit of a long haul of these final few questions, but the last question actually isn't too bad. It's just one of those questions that you kind of need to know, really. And it says, or you know, you might come across, but the equation of a curve is y equals a to the power of x. A is the point where the curve intersects the y-axis. So, okay, so let's just look at that little bit for a moment. Okay, what we've got is a curve, okay, and it goes like that, and it intersects the y-axis at that particular point. Well, if it crosses the axis at the value at the y-axis and the x-axis, at this particular point x equals 0, so x actually hasn't moved anywhere. So what we're saying is that it crosses when x equals 0. Now, if we have a look at this particular equation here, we've got y equals a to the power of 0. Well, anything to the power of 0 is going to be 1. Okay, so that means that y must equal 1. So any number, doesn't matter what it is, to the value of 0 is always going to be 1. So therefore, the equation of where it crosses is going to be x is 0 and y is 1. Okay, so hopefully that's all right for you. It's one of those things that it just, I think after a while it's kind of obvious because you've kind of come across it, but you might not have seen this in this particular context. Okay, and then the last question is the equation of a circle is that. Circle is translated by that to give circle B, draw a sketch of circle B. Okay, well, I'm going to draw a sketch of circle A first, or the first one here, this one here. Well, this is the equation of a circle, so what we've got is the x and y axis. Okay, now, although I've not drawn it particularly well, but basically this, number 16, is r squared. So I've just put a little arrow, and this is r squared. Okay, well, the square root of 16 is 4. So basically what we're saying is that this value must be 4, this must be 4, minus 4 rather, this must be minus 4 as well, and this must be positive 4. Okay, so that's circle C. Okay, and then it says it's translated by the vector 3, 0 to give circle B. So if it's translated by the vector 3, 0, what we've got is we're moving along the x-axis by 3, and we're not moving up and down on the y-axis. So if you can imagine now, we're going to take this circle over a little bit, okay? And rather than being 4, it's now going to be 7 because it's moved along 3 places. Rather than being 0, as it is at the moment, it's moved along 3 places. So this point here, the centre of the circle will be 3. And rather than this being minus 4, it's moved along 3 places towards the right. So that's going to be minus 1 at that point. Now also, it does mean, however, that it's kind of like a rolling sort of tire or a rolling circle. So this point here is still minus 4, and this point here is still positive 4, even though it doesn't particularly look like it on the graph, but actually that's what it would look like. It wouldn't be as squashed as that, perhaps. Okay, I hope that's okay for you. I hope this whole playlist has been useful. Every success with paper 3. I think it's going to be sat next Tuesday at the time of when I'm actually shooting this particular video. Please do add a comment below if you're not sure about anything. I'll always come back to you, and I'll try to get back to you over the weekend before we come back on Tuesday, and I'll look forward to seeing you inside the next video.